Here in this video, we are solving a problem basing on the concept of waves. Let us see what the problem is. Two sources of sound waves placed close to each other, emitting a progress waves given by y1 is 4 sin 600 pi t, y2 equal to 5 sin 600 pi t. An observer is located near these two sources will hear how many beats is the kind of question that you want to calculate and what is the intensity, right? So first of all, if you look at the equation, y1 is given to you as in a format of something like a sin omega t. What is that given for you? 4 sin 600 pi t. So in the place of amplitude A1, I have 4. In the place of omega 1, I have 600 pi. Omega can be written like 2 pi into n1, that is 600 pi. Pi can be cancelled. So n1 is 600 by 2, that is 300 Hz. So the data of the first case, frequency of the first one is saying 300 Hz. Let's find out about the second case. Y2 is given to you as 5 sin 608 pi t, the same format. So amplitude A2 is 5 in SI system. Omega 2 is 608 times of pi. Omega can be written like 2 pi into n. So pi can be cancelled. So n2 here is 608 by 2, that is equal to 304 Hz. So I know n1 and n2. I also know that n2 is greater than n1. So the number of the beats that are generated per second is difference between the frequencies. As n2 is greater, n2 minus n1, 304 minus 300, that is equal to 4 beats per second. So it's going to be 4 beats per second. So it's obvious that this is not going to be like you can see there is a formula like answer like 8 beats per second, 8 beats per second. They cannot be the answers, right? So this is definitely wrong. This is definitely wrong. And I'm more interested in now finding out who is and the correct answer, either A or D. There are two options left out. But I want you to understand the concept rather than eliminating options. So I don't bother about eliminating options that much, right? Now let us see what's the next thing that he is looking for. It is intensity of the ratio between waxing and waning. So I want to explain you something about intensity. Intensity is directly proportional to amplitude resultant of both of them whole square. So waxing means, when you say waxing, intensity is maximum. So intensity maximum is directly proportional to amplitude resultant maximum whole square. That is A1 plus A2. You know, A resultant can be expressed as square root of A1 square plus A2 square, being a wave vector format, cos theta. So for maximum, theta has to be 0. So A resultant is A1 plus A2. That's the maximum value. Minimum value is of course A1 minus A2. Yeah, next one is waning. Intensity is minimum. That is directly proportional to A1 minus A2 whole square. So you want a ratio of waxing to waning, that is I maximum to I minimum, as proportionality constants will be same. Both of them will be cancelled. A1 plus A2 by A1 minus A2 whole square, where A1 is 4, A2 is 5. So A1 plus A2 means 5 plus 4 by 5 minus 4 whole square. That is 9 by 1 whole square. That is equal to 81:1. So it shall have a intensity in the ratio of 81:1, not 25:16. So this is the right answer. Fourth option is the right answer. That's how we have to solve the problem. And to solve this problem, you need to know two basic concepts. How do you find the number of the beats? Of course, how do you find a frequency? Omega equal to 2 pi, and you need to know. And you also need to know that intensity is directly proportional to square of resultant amplitude. That's it. Thank you for watching.